This next section that we're going to look at is graphing. You knew how to graph y equals 2x plus 6, but now we're going to put an inequality in there and graph y is greater than 2x plus 6. Now, there's going to be a couple of new things, but a lot of this graphing is going to be the same graphing of a line that you learned back in grade 10. How do you graph the line y equals 2x plus 6? Well, you would think about y equals mx plus b. What did the b stand for? The y-intercept. So do you see that this one has, this dotted line here, has a y-intercept at 6? And then how did you use the slope? Rise over run. So this means you should go up to, so we go up to 8 over 1, and then you'd get another point, up 2 over 1. I mean, this is where the boxes, you have to be careful. They drew the boxes going up 2, but only going over 1, just to mess you up, right? Yeah. Okay. And then what is new is with an inequality, you have to shade part of the graph. So you draw your line, and after you draw your line, you have to shade either above your line or below your line. So how does it work? A couple of things. If you have, and this is what I like, on the side, I'd like you to write the following. If you have y is greater than, okay, two notes. One, you're going to draw a dotted line instead of a solid line. And two, you're going to shade above. So the equation we had was y is greater than 2x plus 6. The 2x plus 6 line is drawn with a dotted line. And when shading above, if you take any point that's above, so you would shade the part above the line. Does that make sense when I use the word above? You take any point on the line, above is up, below would be down. You shade above the line, you shade that part. And that's the graph. If you had y is less than, you're still going to have a dotted line, but now you're going to shade below. The other inequalities that could appear, you could also have y is greater than or equal. How do you decipher between the greater than and the greater than or equal instead of a dotted line? You have a solid line. And where are you going to shade for y is greater than or equal? Above. And finally, the last possibility is y is less than or equal. You're going to graph your line as a solid line because it could equal the line. And you shade below. So the first example we had was y is greater than 2x plus 6. So it's drawn with a dotted line because there's no equal sign in there. We drew 2x plus 6 as the dotted line and then shaded above. Oops. You already, there we go. The next example, y is less than or equal to 2x plus 6. So now you draw the line 2x plus 6 the same way you would draw the line from grade 10. Start with your y-intercept and use your slope to find another point. And now, because it has the equal sign in it, we draw it as a solid line. And since it's y is less than or equal, we shade below. Y is greater than 2x plus 6. shaded above. Okay. Another way, and this is the textbook saying here, another way you could find out where you shade, if you don't like the idea of shading above and below, is take a point. So they chose a point, and the point they chose was -4, 3. If you plug in -4, 3, so 3 in for y, -4 in for x, is that statement true or false? Is 3 bigger than 2 times -4 plus 6? If it's true, wherever you chose the point, that whole area will get shaded, that whole section. If it's false, the other section would get shaded. But I like the shade above and shade below because it's even quicker. But you can use a test point to figure it out as well. So these are called linear inequalities in two variables. They're linear because it makes a line. There's two variables because all lines have an x and a y. And the way that we do them is we graph our line, either dotted or solid, and then figure out if we need to shade above or shade below. So as far as a few review things from grade 10. And you may want to write this at the bottom of your page. Review of graphing lines. You basically had a couple of methods that you learned in grade 10. One method was the y equals mx plus b. If you change your graph to look like y equals mx plus b, you use the point, which is your y-intercept, and slope, which is m. I guess I can put b inside the y-intercept. Use your point and your slope to graph. Other ways of graphing from grade 10? You could just use the table of values. And once you find 2 points, you can draw the line. Because it's a line, it's going to be straight. So once you have 2 points, that's enough to draw your line. So you could use the table of values, find 2 points. Sometimes people find the x-intercept and the y-intercept to graph it, because those are easy points. Plug in 0 for x, plug in 0 for y. And once you've got those 2 points, you can draw your line. Another thing that we need to review inequalities. With inequalities, equations that are inequalities, you can solve like a regular equation. There's just one special rule. The one special rule is when you multiply or divide by a negative, what do you have to do? You have to switch the thing like that. Let's write flip the sign. Wow, let's sing. So if you are trying to rearrange something to be y equals mx plus b, and you have to divide by a -2, well, then your inequality would change. So let's look at example number 1. Graph the inequality. So what I'm going to do here is I'm going to try and get things to be y by itself on one side to change it to y equals mx plus b. What would you like to do first to change to y equals mx plus b? You want to move the y over? Or well, make a decision. Move the y over or the x? What do you guys, what would you do? You'd probably move the x, okay. And I like that. I like the way you're thinking. Someone didn't want a negative y. That's why they wanted to move the y over. We'll do that next. So if you divided the x over, you would get negative 3y is greater than negative x plus 6. And now to get y by itself, you would need to divide by negative 3. What's going to happen to our sign? It's going to flip. A negative x divided by a negative 3 will be x over 3, which is the same as 1/3 x. The fraction is going to be nice for my slope. What happens when I divide 6 by negative 3? Minus 2. So now that it's in y equals mx plus b form, what's my y-intercept? Negative 2. That's 1 point on my graph. If my slope is 1 over 3, that means I would have a rise of 1, a run of 3. I would have, so I have 1 point at 0, negative 2, and now I have another point at 3, negative 1. When drawing this line, should I draw a dotted line or a solid line? Dotted line. Do you know how many times you're going to, I'm going to show you what's going to happen to you almost every single time. You're going to be like, oh, I'll draw my line. Ah, crap, it's dotted. So you're going to have to like go out and take out your eraser and dot it afterwards. It happens like so many times. You realize you have to make it dotted after you draw it. Anyways, it's supposed to be a dotted line. Now for shading, will I shade above or below? Below, because it's y is less than. So take out your favorite crayon or whatever you like to use for shading. And shade below. And that is our solution. Now someone who wanted to get the y positive, I'll do that in blue. So they first moved the 3y over, and then you would have to move the 6 over. And now when you divide by 3, you don't have to switch the sign. It'll still be 1/3 x minus 2. But if I want to write the y on the left side, you can read this backwards. Can you see that this is y is less than 1/3 x minus 2? So if I wrote it the other way, it still is the same thing. But the sign gets flipped when I switch things around. All right, so you have the rest of class to practice those.